A pleasant day, everyone. Once again, welcome to our session today. So last time I give you a number to solve. This is our example number 3. 3x squared minus 2 raised to the power 4 times x cubed dx. So in our topic, integration by substitution, specifically for algebraic functions. Have you tried this class? So if you have noticed this, this problem cannot be solved using substitution. So if in that case, if you meet or encountered an integral that cannot be solved using integration by substitution, then you may use or you may try using binomial expansion. Okay? Or you can use Pascal triangle. Anyway, that Pascal triangle or Pascal's triangle. That is derived also from this. So you've noticed that this one cannot be solved using integration by substitution. So I will show you that it's not really easy to solve this using substitution. Now, for example, from here we are given this integral of the quantity 3x squared minus 2 raised to the power 4 times x cubed dx. So from here, if we try substitution, so let's check if we can do it. So n is equal to 4 from this given. This is our n. Then we let u be equal to 3x squared minus 2. Right? So if we solve du over dx from here, so this will be 6x, right? Because the derivative of this is 0. And this will go down times 3. So 6x to the power 2 minus 1. So power 1. So this is our du. Du over dx. Then solving for du, so you multiply both sides by dx or you simply cross multiply dx. So you have 6x dx. Okay, so our goal now is if we let this part here as our u, this one, if we let this as our u, it must be our du. But if you look at the result of finding our du or solving this part here in terms of du, we cannot do that because we can only have x dx. If we divide both sides by 6, so we will have x. If we divide both sides by 6, so you have du over 6 equal to x dx. But we know that here we have x cubed dx. So x cubed dx is not equal to x dx. So there's no way that we can find our du here. Okay, so this is an indication, class, that you cannot use integration by substitution. So instead, you may use another method. So the other method here is the binomial expansion method or the Pascal's triangle. So I will solve this problem, class, in two ways. One is using the binomial expansion, and then I'll show you the shortcut method for this binomial expansion, which is the Pascal, using the principle or the concept of Pascal's triangle. Okay, so from here we can use our knowledge from our algebra, if you have u minus v raised to a power 2, so this is equal to u squared minus 2uv, then plus v squared. Okay, so we have that concept learned from our algebra. And if you have, say, if you have x squared, this is just the same as x times x, right? And if you have, say, x to the power 4, this is just the same as x squared times x squared. Okay, so we will use this concept here. So from our given, so our given is, we have here a part, the integrand. Our integrand is 3x squared minus 2 raised to a power 4, right? So we can use this principle here. If the power is 4, you can split it into x squared times x squared. In this case, this is our x. So you have x to the 4th. You can let this be equal to x. So you can also rewrite this as 3x squared minus 2 and raised to a power 2, then times 3x squared minus 2 raised to a power 2. Okay? Then using this concept, if you are given the binomial, the difference of binomial u minus v squared, so this is equivalent to u squared. The first term is square of the first term minus twice the product of the first and second term. You have 2uv, then plus the square of the second term. Okay, so we can rewrite this as square of the first term. So this is 3x squared. You square this one, then minus twice the product, so 2 times the product of 3x squared and 2, then minus square of the second term, which is 2 squared. Okay, so this is our expansion of this part, this one, this factor. Then since they are just the same, you just copy this. So this is also 3x squared squared minus 2 times 3x squared times 2, then minus 2 squared. Okay, so they are just the same. And using the log exponent, so we can write this, you have to square 3, then you have to square x squared. So this will be 9 x to the 4th. Okay, and minus, you have 2 times 3, 6 times 2, 12. So this will be 12 x squared, then minus, sorry, this should be plus class, should be plus because using this formula the third term should be plus, so this is also plus. So this would be plus 4. Okay, so since they're just the same, so you may just copy this. So this is 9x to the 4th, then minus 12x squared, then plus 4. Okay, so in other words, class, we're just expanding, no? We're just expanding this. I just did it not using the binomial expansion formula, but the concept that we have learned from algebra, which is like this. But if you know the how to use the binomial expansion, it's much faster. Okay, so multiplying. So when you multiply the first term and the first term of the first quantity with the first term, so 9 times 9x to the fourth times 9x to the fourth, so this will be 81. This will be 81 x to the, so that from the loop exponent you just add the exponent, so this will be to the 8. So this is coming from multiplication of this. Okay, then next we have to multiply 9x to the fourth multiplied by negative 12x squared. So this will be minus, because this is plus and this is minus. So 9 times 12, so that is 108. So minus 108. Then x to the, so x to the fourth, x squared, so this will be x to the 6 because you just add the exponents. Then next we have to multiply this one. So this will be 9x to the fourth times 4, so that will be 36. And this is plus, so that would be plus 36 x to the fourth power. Okay, then next, this one. What we have done, first term, you multiplied it each term of the second quantity. Then next, you have to multiply the second term with each term of the second quantity. So that would be 9x to the fourth minus 12x squared multiplied by 9x to the fourth. So that will be, so since this is negative, this is positive, so this will be minus. So 12 times 9, so that is 108, no? 108 x to the, so you have x squared then x to the fourth, so that is x to the 6. Then next is this one, second term to the second term, so 12x squared multiplied by 12x squared, so minus minus, so that will be plus. 12 times 12 is 144, then x to the power, so you have x squared and x squared, so that will be x to the power 4. Then next, second term to the third term, so that is 12 times 4, so that will be, then this is negative, so this will be negative. So 12 times 4 is equal to 48. Then x to the power 2. Okay, so next, so we don't have to space anymore, so we have to put it down. No? So next is the third term individually. First term, so that would be 4 times 9, that is 36 to the power 4. 36 to the power 4, and that is plus, so I'll just put it here. So 36 x to the power 4. Is it correct? 4 times 9, so 36 to the power 4. Okay, let me check. Okay, it's correct. Then next we have 4 times minus 12, this one. So 4 times minus 12, so negative. So that is minus 48. So that is minus 48 x squared. So I will find a term that contains x squared. So we have x squared here, also 48. It's negative, so I'll put it here. 48 x squared. And then we have 4 times 4. So 4 times 4 is 16. So plus 16. Okay, and then combine similar terms. So combining similar terms. So we have, first let us write this first term. Our first term is 81. 81 x to the power 8. Then minus. So we have similar terms here. We have negative 108 x to the power 6 and negative 108 x to the power 6. So meaning twice of that. So 108 times 108 plus 108, but negative. So they are 216. 216 x to the 6. So we already combined these two. Okay. And then we have x to the power 4. So let us combine all the x to the power 4. So we have here 36, positive 36 x to the power 4. And we have 36 to the power x to the power 4. And then we have here positive 144 x to the power 4. So when you add those, so what's the sum? So 72, no? We have 36 plus 36. When you add this 2, 36 plus 36, 72. 72 plus 144. So 144 plus 72, 6, 11, carry 1. So that is 216. So that is also 216. So this is plus 216 x to the power 4. Okay? And then you have x squared. So you have a term that contains x squared, negative 48x squared. Then we have negative 48x squared. So combining them. So what is 48 plus 48? So that is 96. Right? That is 96 minus 96 x to the power 2. Okay? Then we have the constant, which is equal to 16. So plus 16. Okay, so 81 x to the power 8 minus 216 x to the power 6 plus 216 x to the power 4 minus 96 x to the power 2 plus 16. Okay, so that is the result of this part class. When you expand this binomial with the power 4, so this is the resulting expression or expansion. So now what we are going to substitute this. Now we are going to substitute this in this integral. So we will have integral. I'll just copy this one class. So from here, okay, so from here, so we have the integral of instead of 3x squared minus 4 to the power 4, so we will write this. Okay, we have to replace this. We have to substitute this one here. This one we have to substitute it here. Okay, so this will be integral of I will rewrite that first. So integral of 3x squared minus 2 to the power 4 x cubed dx. Okay, so equal to, so instead of writing this, you may write this one. So integral of 81 x to the power 8 minus 216 x to the power 6 plus 216 x to the power 4 minus 96 x to the power 2 plus 16. Then you put this inside the parenthesis, okay, and then multiplied it by x cubed dx. Okay, so this is times x cubed dx, so x cubed dx. Okay, so after that, we are going to distribute this integral sign together with this x cubed dx. So we can rewrite this as okay, I will put the equal sign here, class, because we will be short of the space. Okay, so this will be integral of 81 x to the 8 then multiplied by x cubed dx, then minus integral of 216 x to the 6 multiplied by x cubed dx, then plus integral of 216 x to the 4th then multiplied by x cubed dx, then minus integral of 96 x squared times x cubed dx, then plus, I put it here, integral of 16 times x cubed dx. Okay, so to continue, I hope you can still see the, anyway, I will use another cardboard, class. Okay, so to continue, so we can combine, no? Alright, so I will rewrite, class, the last part. So we have the integral of 81 x to the power 8. So we multiply this by x cubed dx, then minus the integral of 216 x to the 6 multiplied by x cubed dx, then plus integral of 216 x to the 4th multiplied by x cubed dx, then minus integral of 96 x squared multiplied by x cubed dx, then plus the integral of 16 times x cubed dx. Okay, and then isolating the constant, integrating individually, isolate the constant. In this first term we have 81, and integral of, then multiply x to the 8 and x cubed, so this will be x to the 11 dx, minus 216 integral of x to the 6 times x to the 3, so that would be 9 dx, then plus 216 times the integral of x to the, we have 4 and 3, so you just add, so that is 7 dx, then minus 96 integral of x to the, we have 2 and 3, so that would be 5 dx, then plus 16 integral of x cubed dx. Okay, so using the power formula, so we have 81 x to the 11, so n plus 1, so this would be x to the 12 over 12, then minus 216 x to the 10 divided by 10, then plus 216 x to the 8 over 8 minus 96 x to the 6 divided by 6, then plus 16 x to the 4th over 4, then plus c. Okay, then we have numerator, denominator, numerator, denominator, numerator, denominator, numerator, denominator, numerator, denominator. So let's find out if we can divide. If we cannot, then we just reduce to lowest term, no? So we can, for example, here, this is divisible by 3. This is also divisible by 3, but this is not divisible by 12, so we cannot make it 1. But the only way is to divide this by 3, divide this by 3. So we have 81 divided by 3 is equal to 27. Then 12 divided by 3 is 4. So this will be 27 x to the 12. Then minus. So this one is not divisible by 10, not divisible by 5, but divisible by 2. So when you divide this by 2, so this will be 108. Then divide this by 2 also. So this is over 5. Then x to the power 10. Then plus. So this is divisible by, I think this is divisible by 8. So when you divide 216 by 8, so that is 27. So kindly double check class. So 27 x to the 8. Then minus, so 96 divisible by 6, that is 16, no? 16. So this is 16 x to the 6. Then plus, of course that one is divisible by 4, so this is 4 x to the power 4, and plus c. So this is our answer. Okay, so this is still integration by substitution, but you cannot do it in the way that we have done it in our previous two examples. But this one, it involves binomial expansion. So this is the first solution for this example. I will show you another solution for this one using Pascal's triangle in our next video. Okay, so if you have any question, please message me at our GC. Thank you very much. See you later in our next video. Bye.